So in the factor theorem, we're going to let p of x be a polynomial function, and then x minus c, this binomial, is a factor of p of x if and only if, remember our remainder theorem, if we were to plug in c into that function and we get a 0, that means no remainder. It divides evenly. And also, this term if and only if can be written as IFF in shorthand. You might see that later on in calculus as well. And it just means it works both ways. If x minus c is a factor of px, then we know the remainder is 0. Also, if we plug it in and we get a remainder of 0, then we know that it's a factor. Okay. So that's the part 1 and the part 2. It goes both ways. We just want to kind of recap here that if p of c equals 0, then c is a 0 of p of x. So we can also state the factor theorem as follows. C is a 0, which again is a root. We can think of it as an x-intercept, 0 root of the polynomial p of x, if and only if x minus c is a factor of p of x. All of these are telling us the same thing. Our y value is 0, therefore it lands on the x-axis, so it's an x-intercept or 0 or root. But also, if it's a 0, that means it is a factor. The x minus that value is a factor of the polynomial. It would divide in evenly. So let's move down here to the second example, where we're letting p of x equals the x cubed minus 7x plus 6. And we want to show that x minus 1 is a factor of p of x, and use this fact to factor it completely. If we know that this guy is a factor, that means the remainder, if we were to divide, would be 0. We can do the remainder theorem, p of 1. If I plug in 1, see if we get a 0. 1 cubed minus 7 times 1 plus 6 does in fact give us a 0. So by the factor theorem, x minus 1 is a factor of the polynomial p of x. Now it says it wants us to use that fact in order to factor it completely. That's where the division, either synthetic or long division, comes in handy, because then we can just kind of keep factoring those smaller pieces. So let's practice the synthetic only because it's faster. So here our 0 is x equals 1. So we're going to divide by that 1. And again, our original equation is x cubed in descending powers would be plus 0x squared minus 7x plus 6. Every type of term from the largest to the smallest has to be counted for. And then we put in those coefficients. 1, 0, -7, and 6. So we bring down the first one, multiply, combine, multiply, combine, multiply, and combine. So we do have a remainder of 0, and these are the coefficients of the other factor. So we get an x squared plus x minus 6. And again, how do we know it's an x squared? It's just 1 degree smaller than what we started with. If it's an x cubed, then that first coefficient belongs to an x squared. If we started with an x to the 5th, then that first coefficient would go to an x to the 4th, and it just decreases down. So now we have the x squared plus x minus 6, which we can factor. That factors into x plus 3 times x minus 2. And don't forget the first factor that they gave us. So p of x factors into x minus 1 times x plus 3 times x minus 2.